Hello students, good morning. Welcome to another video. Vedantu Karnataka. This is Catherine, your physics master teacher. Okay, today we're going to do, you might have all seen the thumbnails. Today we're going to do 31 questions that can help you score 55 marks. Okay, so these are taken from previous papers. I've included 2 markers, 5 markers, 3 markers, and all of those. Okay, so let's start. So before you start, quick reminder, your MVZ exams are on the 11th and 12th. Please don't forget, make sure you write those as well. Okay, let's start. So question number 1 from the first chapter. Write 3 properties of electric field lines. So what are the different properties of electric field lines? They always start from the positive, okay? And they end on the negative. So if there's a negative charge, the field lines go in. No field lines intersect each other. The more closer the field lines are, the stronger the field. So as you move away from the charge, the field lines become weaker and weaker. Second question. Derive an expression for torque experienced by an electric dipole placed in a uniform electric field. Okay, so you have a dipole. What is a dipole? Dipole is a plus charge and a minus charge separated by a distance. Okay, so if you have plus charge and a minus charge separated by a distance, and this dipole is placed in an electric field, plus q experiences a force because of minus q experiences a force because of plus q. What is the force that plus q experiences? It is QE. The force that minus q experiences, minus QE. Okay, and how do you find torque? Torque is basically PE sine theta. In vector form, it is P cross E. Okay, yeah, I hope you're able to see it properly. Okay, next question. Derive an expression for electric field at a point on the axial line of the dipole. Okay, so if you have a dipole, again a dipole which has negative charge and positive charge, to find out the electric field at a point P, which is along the line. So for this derivation, the equatorial is also important. Anyone can come for your exam. Okay, derive the expression for electric field at a point on the equatorial point of electric dipole is also important, but this is axial. I've just put 1 here. Okay, so E is 1 by 4 pi epsilon 0 q by, so generally E is what? E is 1 by 4 pi epsilon 0 q by r. Yeah, so r is the distance between the point and the charge. So here for minus q, what is the distance between point P to minus q? Point P to minus q, the distance is r plus a. For P to plus q, the distance is how much? P to plus q is r minus a. So I just have to substitute r as r plus a and r minus a, and then add the two, you will get the final answer. Okay? Okay, next question. Use Gauss law, derive the expression for electric field due to an infinitely long straight uniform charged wire. So you have a long charged wire, okay? So for this long charged wire, you make a Gaussian surface around it. A Gaussian surface is a surface where the charge is equidistant to all the places on the surface. So if it's a straight line, a Gaussian surface will be a cylindrical body. Okay, so what things that you need to know are Gauss law. You need to know phi is q by epsilon naught, which is Gauss law, and here q are the charges. So it's along a line L. So along the line L, there are lambda charges. So L into lambda can be represented as q by epsilon. Okay. Now phi is also equal to E times 2 pi r into L, because it's a cylinder. Yeah. So this is also equal to L lambda by epsilon. Okay. Now L and L cancel, you cross multiply, you will get E is equal to lambda 2 pi epsilon naught r. Okay, now this one, same Gauss law for a sheet. See, Gauss law for spherical shell. All the applications of Gauss law are very important. I've just put 2 here. Okay, this is just a reference. So all the other applications of Gauss law are also equally important. Okay, so here what happens? I have a sheet of charge. In the previous case, I had a long strip of charge. Here I have a sheet of charge. Okay, so this sheet of charge, I take a small area on the sheet of charge. So for this area, I draw a cylindrical Gaussian surface like this. Okay, so you take, the whole Gaussian surface, but here you don't take the area of the whole cylinder. You take area of the two spheres. at the entrance and at the end of the Gaussian surface. So if this is a whole cylinder, you take this side and this side. You don't take the cylinder like in the previous question. That's because along the cylinder, electric field and the area vector, they're perpendicular, so they cancel out. Okay. Only on these two sides, electric field and area vector are parallel. So you take this side as E into area, this side also E into area. So you will get phi is 2 times E into area. Okay. So phi will be 2 times E into area. Alright, 2 times E into area, and then again Gauss law Q by epsilon naught. But here Q is along a whole area, not just a line. So instead of L, instead of length, I'll put area. The number of charges or charge density, I'll put it as sigma. Okay, so A sigma by epsilon naught. Alright, so y is equal to, and then you cross multiply, you will get E is equal to sigma by 2 epsilon. Okay, next question. Electric potential and capacitance. Define electrostatic potential. Electrostatic potential at a point is defined as the amount of work done by an external agent to bring a unit positive charge from infinity without changing its kinetic energy. Okay, so if there's a charge at infinity, you bring it, and the amount of work done to bring it is electrostatic potential. What is SI unit? SI unit is volts. Volts, where 1 volt is 1 joules per coulomb. What is electrostatic shielding? Electrostatic shielding is a phenomena by which a region, okay, it is protected from external fields by enclosing it with a conductor. So you take something, cover it with a conductor and protect it from any external field. Okay, one common example is a Faraday cage. So if you have some electronic equipment, you put it inside a Faraday cage, so no external fields will enter it. Okay, it's like you hold an umbrella to protect yourself from rain. Just like that, a conductor holds a cage around it to protect it from external electric fields. Okay, okay. Next question. Write the expression for electric potential at any point due to an electric dipole. So yeah, electric potential at any point is given by V is equal to 1 by 4 pi epsilon naught P dot R cap by R square. What is V? V is the electric potential. P is the dipole moment. R is the distance from the center. And P dot R is what? This is basically 1 by 4 pi epsilon naught. P dot R can be written as P cos theta. Yeah, divided by R square, where theta is the angle between the dipole axis and the position vector. Why is electrostatic field 0 inside a conductor? See, why is there an electrostatic field? Because of free electrons, right? So inside a conductor, free electrons rearrange themselves such that they all cancel out. Okay, so that is why inside a conductor, electrostatic field is 0. Okay, yes. In the expression for the relation between electric field and potential, what are two important conclusions we arrive at? The electric field at a point is equal to negative gradient of potential. Okay, E is equal to minus dV by dr. This derivation I think you have in first PU as well. A uniform, I'm not sure, is it first PU? Okay, forget it. Something crossed my mind. A uniform electric field corresponds to a constant potential. There will be an electric field only if there is a change in potential with distance. Okay, good to go. Next, derive an expression of electric potential due to an electric dipole. So here we have to derive an expression for electric potential. Okay, same thing, similar thing can be done for electric field due to an electric dipole and an equatorial. Okay. So here again what we are going to take? We are going to take the potential because of charge plus Q, potential because of charge minus Q, and then add them. Okay, you add them, you take 1 minus 1 by R2 by binomial expansion, and then you substitute dipole moment as Q times 2A. Are you able to see it? Yeah, I hope you're able to see it now. Okay? Okay, next question. Derive an expression for capacitance. Arrive at an expression for capacitance of a parallel plate capacitor. So capacitance is given by C is equal to Q by V. Okay. We already have learned that formula. So this formula is used in multiple places. Okay. So E is what? Sigma by epsilon naught. See, what is a capacitor? Two plates that have area A and A separated by a distance D. Yeah. So the electric field between the plates is given by sigma by epsilon naught. How did I get that? See, I've already taught you in a Gauss law question. If you have a plate, Q is always A times sigma. So from this, sigma is Q by A. That's all that I've taken here. Okay. Q by A. Now we've already learned potential difference between two plates is equal to the product of the electric field and the distance between the plates. So V is equal to E into D. So this is the answer. So C is Q by V. C is K epsilon naught A by D. Okay. Next question. Derive an expression for effective capacitance of a series combination of two different capacitors. Okay. So if you have two capacitors that are series, okay, one capacitor, second capacitor, they are at series. Both these capacitors have capacitance C1 and C2, two different values of capacitance, but they have the same charge Q, okay, and they have potential V1 and V2. Okay, in series, the potential is not the same for every component. So first thing you need to know, in a series combination, the two capacitors have different capacitance, different voltage, same charge. And then we do the derivation. So what is the formula? Q is C1V1, Q is C2V2. What is the total voltage? It's different. So total voltage is V1 plus V2. And then you write it as Q equivalent is C equivalent times V. So this is basically Q by C1 plus Q by C2. Eliminating Q, you will get 1 by C is equal to 1 by C1 plus 1 by C2. Now, same question they can ask you for parallel combination as well. That also you should learn. For parallel combination, the only thing that you need to remember is voltage is the same, charge and capacitance are different. Okay, so it will be Q1, Q2, C1, C2. Excuse me. And V and V. Okay, voltage is going to be the same for both. It's going to be V and V. Yes. Okay. Now from current and electricity, state and explain Ohm's law. See, Ohm's law, what does Ohm's law states that V equals IR. Current flowing through a conductor is directly proportional to voltage provided temperature and other physical quantities are constant. Very important law. How long does the resistance of a current carrying conductor vary with length and area? So resistance is directly proportional to length. It's inversely proportional to area. Okay. So if length doubles, resistance doubles. If area increases, resistance decreases. Directly and inversely proportional. And that comes from this equation. R is equal to rho L by A. Mention the expression for resistance in terms of resistivity. Yeah. R is equal to rho L by A. So if I remove rho, R is proportional to L by A. That's how I did the previous question. Okay, so it's directly proportional to length, inversely proportional to area. Okay. Okay, next question. Derive an expression for electric current in terms of drift velocity and number density of free electrons. So let's say electrons moving in, in a length in time t. So they will have length is distance is speed into time. So here distance is length, speed is Vd and time is t. So L is Vdt. Now number of electrons will be how much? N times the volume AVD into T. So Q is what? Q is the number of electrons into the charge of one electron. So NAVDT into E. Now I is charge by time. So you just divide the formula of charge by the formula of time. You will get this final answer. Okay. Okay. Assuming the expression for electric current, arrive at an expression for electrical conductivity. That's also easy. So current density is what? Current by area. So if you divide the formula of current by area, you will get NEVD. Okay. So we've already learned that VD is what? E tau by M. Okay. So J will be equal to NE times VD. Instead of VD, I'll write E tau by M. So this will become NE square tau by M. So the whole thing I'll take it as sigma. So this will be sigma. J is equal to sigma E. Right. So this NE square tau by M, I'll take it as sigma. Okay. Yeah. Next question. Derive an expression for equivalent EMF and internal resistance of two cells connected in series. So let's say you have two cells connected in series, they have EMF E1 and internal resistance R1. He has EMF E2 and internal resistance R2. Okay, so E equivalent is E1 plus E2, R equivalent is R1 plus R2. So the total resistance of the whole circuit will be how much if it's connected to another resistor? This is a series circuit. So this will be R plus R1 plus R2 will be the total resistance of the series circuit. That is what is given here. And from Ohm's law, I is equal to V by R. What's the total voltage here? It's the total EMF. So it will be E equivalent divided by the total resistance is R plus R1 plus R2. Yeah. So from that you will get E equivalent is E1 plus E2, R equivalent is R1 plus R2, and I is E1 plus E2 divided by R1 plus R. R plus R1 plus R2. Okay. Same thing for parallel is also important, students. So make sure you learn that as well. Next, from moving charges and magnetism, first question. Write the vector form of Biot-Savart's law and explain the terms. So what does Biot-Savart's law say that? It says that dB is equal to nu 0 by pi 4 pi I dl cross r divided by r cube. Okay, it says that the magnetic field at a point due to a small current element is directly proportional to current, length vector and sine of the angle between them, and the position vector is also inversely proportional to the square of the distance r. Okay, so dB is a very small vector, mu 0 is the permeability of free space, I is current, dl is length, r is position, and r vector is position, r is basically the magnitude of r. Okay, next question. Biot-Savart's law? No. Write the expression for magnetic field at a point due to current element and explain the terms. Okay. Nu by 4 pi I dl sin theta, it only asks for the expression. So only expression is required. dl is the length. You have to write down what each is. Explain the term. So this is probably a 2-mark question. Okay. So dl will be the length of the current element. Theta is the angle between them. R is the distance from the element. Magnetic field. Okay. Yeah. What is the maximum field at a point due to a current element? So maximum is when theta is 90 degree. So basically dl should be perpendicular to r. Or if dl is parallel or anti-parallel to r as well, it will produce a zero magnetic field. Okay, next question. Derive an expression for the magnetic field at a point inside an air-cooled long conductor solenoid by using Ampere's circuital law. So you take a solenoid and in the whole solenoid you take a small element. Yeah, in the whole solenoid you take a small element. Okay, and that element you find out the magnetic field at that for that element. So that's a small rectangular element. So it has this part, this part, this part, and this part. So all the 4 parts. So if I take my element like this, here you can see. Okay, so there's A, B, C, D. So there's magnetic field along AB, BC, CD, and AD. Okay, so all the 4 you have to take. So the ones that are perpendicular are going to be 0. So you can cancel them out. So the only ones remaining are AB, which is inside the solenoid. DC is outside the solenoid. So the only one remaining is AB. Okay, so that's how you take integral B dot dl is equal to B dl AB. Okay, and then you just substitute the numbers. Okay, I hope it's clear to you. I mean, visible to you. Okay, next question. Derive an expression for force between two long straight parallel conductors. So you have 2 conductors, they both carry current in the same direction. Okay, so basically they will have a force because every current carrying conductor has a magnetic field around it. So 2 long current carrying conductors have 2 magnetic fields around it. Yeah, so since they have magnetic fields around it, they will have a force as well. Yeah. So the magnetic field is given by B is equal to mu 0 I 2 pi r. Force is what? ILB, the formula that we just learned. And then instead of B, I'll substitute mu 0 I by 2 pi r. And then I'll get the answer. Okay. Next question. Explain the working of a moving coil galvanometer. Okay. So moving coil galvanometer, it has a coil Okay, this coil is connected to a pointer, and whenever the coil has a change in, whenever the coil experiences a force, the pointer will move. All right. So how do you get the torque? Torque is NIAB. So torque makes the coil move, but the coil comes back. Yeah. So there's a restoring torque as well, which is K theta. You equate the two and you get the answer. Okay, now from the next chapter, three properties of magnetic field lines. They form closed curves, they don't intersect, if you want to find out the direction of magnetic field, you just have to draw a tangent at any point. Explain Gauss law in magnetism, write its significance. What does Gauss law states that magnetic field through any closed surface is always zero. That means magnetic monopoles can never exist. That's the significance. Okay. So B dot dA is zero. Next, derive the expression for potential energy of a dipole placed in a uniform magnetic field. Potential energy is what? mb sin theta. So you just have to integrate it. So you will get minus mb cos theta. When you integrate it from theta 1 to theta 2. Because it's a dipole, it's rotating. Yeah. So initially the angle is theta 1, then it goes to theta 2. Okay. Three properties of diamagnetic material: weakly repelled by field, relative permeability less than 1, magnetic properties are independent of temperature. Same thing for para and for ferro also, they might ask you. Okay, all of these you have to write. Next chapter is electromagnetic induction. What is an AC generator? It's a device that converts mechanical energy into electrical. Okay, so for an AC generator, you'll see that it has a coil. Okay, it has a coil between two magnetic fields. Okay, so this coil continuously rotates mechanically. So when this coil rotates, it continuously cuts magnetic field. Okay, so the coil is in the presence of a continuously changing magnetic field. This produces a current, and that current is what we get in an AC generator. And this process is called electromagnetic induction. All right, derive an expression. Expression is just the total EMF is basically d phi by dt. Okay, so when the coil rotates with angular velocity omega, it will make an angle theta, which is omega t with the field. Okay, next question is alternating current. From alternating current, write the phase difference between the current and voltage in the case of purely resistive circuit and purely capacitive circuit. Okay, so for purely resistive circuit, current and voltage, they have the same phase. So phase difference is 0 degree. Purely capacitive circuit, current leads the voltage by 90 degree. So phase difference will be 90 degree. What is the average power dissipated over a complete cycle of AC? If it's a pure resistive and a pure inductive. So if it's a pure resistive, the maximum is given by P is equal to VI. So V and I are both RMS values of voltage and current. If it's a purely inductive, then the average power dissipated is 0. Why? Because current lags voltage by 90 degree. Okay? Yeah. Next question. Write any two differences between inductive reactance and capacitive reactance. What is inductive reactance? XL is equal to omega L. And what is capacitive reactance? XC is 1 by omega C. Okay. So in the first case, current lags by voltage by 90. In the second case, current leads voltage by 90 degree. Okay. Next is, what is a transformer? What is its working principle? So a transformer is basically used to step up or step down current. Okay. So if you know, we have the main power supply, power grid, or wherever you have this big electricity generation happening. From there you have wires and then it reaches your house. Okay. So if the power that is generated there goes just like that to your house, it has high electricity. Okay. So if high electricity passes through a wire, it will heat up the wire. So what is done is, here you have a step up transformer. Okay. And near your house, you have a step down transformer. Okay. So we know that power is voltage times current. Here also power is voltage times current. Okay. So what we are going to do is, maintaining the power, we step up the voltage, decrease the current. So let's say 500 was the power. Okay. And let's say voltage was initially 10 and This was 50, current was 50. You interchange. You increase voltage to 50 and reduce current to 10. So total power is still 500. And then you transmit over long distance. Since current is less, what happens? It won't produce heating, no energy is lost. And then when it reaches your house, it goes to the step down where it's converted back to the original. Voltage is reduced, current is increased, and then it is taken to your house. Two differences. Step up, voltage increases, step down, voltage decreases. So number of turns will be more in secondary. Why? Step up has more output voltage. Okay. Next, write the expression for displacement current and explain the terms. What is displacement current? ID is equal to epsilon naught d phi E by dt. Okay. What is displacement current? Write the expression for speed of light in vacuum in terms of permeability and relativity. So ID is epsilon naught d phi E by dt. C is equal to 1 by square root of mu naught epsilon naught. Two properties of electromagnetic waves, they are mutually perpendicular. They have the same speed of light when they travel in vacuum. Okay, so I've discussed almost more, I think a little more than 31 questions. So these are all very, very important questions, students, but you have to learn the add-ons to these questions as well. For example, if series I've discussed, you have to learn parallel also. If one application I've discussed, you have to learn the other applications also. Okay, so hope you all enjoyed this short session, a quick revision for all of you. If you want to know the detailed answers of all of these questions and how each step is and all that, you can watch the 1 markers, 2 markers, 3 markers and 5 markers video uploaded on our channel where we've discussed all of these questions in utmost detail. Okay, all right students, all the best, very best for your exams. Take care. Bye bye.